Okay, so we're going to finish up section 2.4 here with something called the intermediate value theorem. In calculus, we have a number of important named theorems that kind of keep coming up over and over again, and we'll use them later to prove more theorems. And so they're just kind of these touchstone theorems that are like the essential theorems of calculus. And the intermediate value theorem is, I guess, the first of those that we are encountering in our lessons. So this is a really simple, very intuitive statement that is true, but which is nonetheless like really profound in some ways, and it will sort of, its impacts will echo across the study of calculus, and we'll occasionally refer back to the intermediate value theorem and say, yeah, remember that really basic fact that that seemed obvious? Well, we're going to use it here, and it's gonna, we're going to prove something with this basic fact that is maybe not so obvious. So it says this: if you have a continuous function f of x and it's continuous on a closed interval from a to b, and if the f of a and the f of b, the outputs of the function at those endpoints, are different from one another, in particular f of a is smaller and f of b is bigger, and if you have any number, we're going to call it k, which is in between those, this would be like a y value, then there will exist, guaranteed, some number called c in between a and b, such that the function value of c equals k. Now, saying it like that is a little hard to work with, so let's just look at our y-axis and our x-axis. On the y-axis, we're saying f of a and f of b are going to be in that order, with f of a being the smaller number and f of b being the bigger number. And this k is some number in between them. Any number you want that's in between those. Now, a to b is our closed interval, so let's have a be here and let's have b be here. And so a f of a is a point on the function, and b f of b is a point on the function. And our function is continuous on this closed interval, so I have to be able to draw the function by starting at this point and going to this point without picking up my pencil. So maybe the function looks something like that. Sure, that'll do. So what the intermediate value theorem is saying is that given any k you want in this interval here, you're guaranteed that there will be a point on the graph of the function at height k on this interval. And there's the c value that is guaranteed by this theorem. It's in between a and b, and in particular, for this example I drew, it's right there. Okay. Now you might say, well, maybe you just drew a weird function, right? And maybe that for this function you drew, it happens to work. Maybe you could draw another function that's continuous and connects this point to this point, and maybe it wouldn't work. Well, turns out, no. Any function you draw from this point to this point, which is continuous, will be guaranteed to cross this line at height k. Guaranteed. So you can play a little game with yourself, which is sort of fun. If you make a rectangle, and let's put this point over here. This is going to be our a f of a point. And this point up in the top right corner is going to be b f of b. Okay. And let's pick a k value. Okay. Let's have it at that height right there. It doesn't matter which height you pick. You can pick any height you want. That's part of the game. Any height between the top and the bottom of the rectangle. Now, the game is to draw a line without picking up your pencil that goes from this point to this point, but doesn't cross over that dotted line. Can you do it? I mean, let's try. Nope. Well, that didn't work. There's C. Well, maybe I can go like over here, but I gotta get up there eventually, so, oh, yeah, no matter how hard you try, it's just not gonna work. Maybe we can go really fast. Oh, too bad. There's C. So it's obvious, right? Yeah, it's totally obvious. But this theorem is, like I said, going to be pretty important later on, and it's going to kind of help us prove other things that are pretty handy-dandy. So that's the basic idea. I'm going to post a really neat video that I discovered on YouTube a number of years ago. Some of you may be familiar with the channel Numberphile. Numberphile did a wonderful video featuring this lovely, I think, German mathematician who explains an application of the intermediate value theorem. By the way, in the video, he accidentally calls it the mean value theorem, but that is corrected in the video with a little text. It is the intermediate value theorem, and he shows you how you can fix a wobbly table. So I'm going to post that for you to check out on D2L.